Hello, hi, good morning, my dear students. Welcome to the chemistry class. So, in the last class, we have seen that how to write the electronic configuration, and based on the electronic configuration, how to recognize the position of the element in the periodic table. Based on the position of the elements in the periodic table, it is possible to say the properties. How and how can we say that it is a physical or the chemical property, and it will be explained based on today's class. So let's begin. So here I have written the electronic configuration, general electronic configuration of 4 blocks. So look here. So you know that in the periodic table it is classified into 4 blocks: S, P, D, and F block. So look here. The element which are outermost electrons are filled in S orbital, those are called as S block element. If the outermost electrons are filled in P orbit, then it is called as P block element. If the outermost electrons are filled in D, then it is called as D block element. Similarly, if the outermost electrons are filled in F, then it is called as F block element. So sometime for 1 mark you may get a question like this: write the general electronic configuration for S block. S block means, so S block elements, all the elements have the outermost general electronic configuration. At the end it will be the form of NS1, N may be 1, 2, 3, 4 like that. S may have 1 or 2, it do not exceed more than 2. So this is the general electronic configuration of S block. Are you getting it? It will be asked for 1 mark. Generally, same thing, the P block elements, it is having the general electronic configuration. NS2 means S should be completely filled by 2 electrons, and then it begins to fill the P. So from P it may be a 1 or up to 6. So NS2, NP, 1 to 6. So these two should have same number. 1 means here also 1, 2 means 2, 3 means 3. So this is the general electronic configuration of P block element. So next one. So this is the D block elements having the general electronic configuration N-1, D1 to 10, NS 0 to 2. So what we have written like this means, actually we have to write we are writing that the NS2 initially, but why I have written in this means, sometimes what happens, the S block if it is filled by 2, that electrons will be received by the D orbital. For that reason we have written N-1, D1 to 10 means D orbital may have electrons from 1 to 10, maximum is 10. So here what N-1 is nothing but, here it is 2s, then here 2 minus 1. Here if it is 4s, then you have to take 4 minus 1, that is 3. So whenever you write the electronic configuration of 21, 22, 23 up to 30 or 40, 60 like that elements, you will come to at the end you will be having the electronic configuration based on this series. Therefore it is called as the general electronic configuration of D block. Similarly, you are never going to get the example, or if you want you can write that one, but in the examination part they will not ask you to write the electronic configuration of elements which is having the atomic number more than 70 or 50, because F block elements are coming more than 50 and 70. For that reason you may have the maximum probability to ask the question. Write the general electronic configuration of F block. Only F blocks general electronic configuration you may have, but they are not going to give the atomic number of that larger atomic number, so that element belongs to the F block. So look here, N-1 F1 to 14, because F block elements are having electrons 1 to 14. N-2, this is N-1, D 0 to 1, N is 2. Can you see here first S orbital will fill 2, and D it may have only 1 electron or it may have the 0 electron. It means that the electrons will be received by the F to make it as a stability, but you are not having the larger explanation of about F block elements or its electronic configuration in your syllabus. Therefore N-2 F1 to 14, N-1 D0 to 1, N S power 2. So this is the general electronic configuration of F block element. So look here, it will be important for 1 mark, keep in your mind. So here you know S block elements are nothing but it is the first group and second group elements are called as S block. In that the first group element is called as alkali metals. You are not going to get that in an exam, but you should know for a general purpose. Alkali metals are nothing but generally the elements of first group. First group elements are called as alkali metal, and second group elements are called as alkaline earth metal. The second group elements are nothing but those are called as alkaline earth metals. Alkali metals and alkaline earth metal. This is about the basic elements. Second one, P block elements. So P block elements ranges from 13 to 18. 13 to 18. So in this P block element, the most important is only two group, that is 16 group and 17 group. The 16 group is called as chalcogen. Chalcogen. Here 16 group elements are nothing but what? Oxygen, sulfur. These are called as, these are belongs to the 16 group. So therefore these 16 group elements are called as chalcogen. What are chalcogen? Which group is called as chalcogens? Or give the example for the chalcogens. You may get such questions. So next one is 17th group. 17th group elements are called as halogen. So halogens are nothing but the elements which are belongs to the 17. That is fluorine, chlorine, bromine, and iodine. So these are called as halogen. One more element is there, but we are not calling that as a halogen. For that reason, we are not writing them. So halogens are nothing but 17th group element. You should know the name of this number. In detail about these S, P, D and F you are going to study in detail, because separately you are having one chapter based on each of the block. For that reason, it is a brief explanation in this chapter, and in the next chapter onwards you are going to study in detail about the S block separately and P block separately, D and F. Are you getting my point? And this chapter will be continuous even for the second PUC also. In first PUC, yes, and in P only some portion, means some P block elements you are going to study. In second PUC the same portion will be continued. In second PUC you are going to study remaining P block element. D and F together you are going to study D and F block elements. Means the portion is divided in first PUC and even for the second PUC. Is it okay? So next one, D block elements. Generally the D block elements are called as transition element. Transition elements are nothing but D block elements. So D block elements are called as transition element. What is transition element? So 1 marks they may get the question. So don't say that the D block elements are called as transition element. Yes, obviously it is right only, but it's having some special definition. So here D block elements are the transition element, but not all the elements are transition element. Why? Because but the elements which are belonging to the at the end. So you know that the D block begins from group 13 to group 12. The 12th group which are belongs, those are not called as a transition element. Why? Because for example, all the elements of D group are called as a transition element, but not zinc, cadmium, capital C, small d, cadmium, and mercury. Zinc, cadmium and mercury, these are not called as transition element. So what is the transition element? Transition elements are nothing but the elements which are having the electronic configuration of D. D should have partially filled the D orbital. The elements which are belonging to the D block only, but the transition elements are nothing but they should have the partially filled D orbital. The electron should be partially filled in the D orbital. So it means that D1 is nothing but a first element in the D block. D2 means second, D3 means fourth, up to D9 it is partially filled. If I say that D10 means the electrons are completely filled in the D orbital. Isn't it? 1, 2, 3. D1 means 1 electron, D2 means 2. This is 4, 5, 6, 7, 8, 9. Can you see here? Up to 9 it is called as partially filled. Partially is nothing but half filled. Somehow it is randomly filled, but not completely filled, and it is not fully empty. Can you see that? The element should have at least 1 and maximum 9. If it is 10 means it is called as completely filled electronic configuration. If it is completely filled electronic configuration like D10, if it is having the electronic configuration, then we are not calling that as a transition elements. So elements which are partially filled D orbital, partially filled are nothing but the electronic configuration should be from 1 to 9, then it is called as transition element. So what is transition element? The elements which are having partially filled electrons in the D orbit is called as transition elements. But Even though zinc, cadmium, mercury are belonging to the D block element, but it is not considered as a transition element. Why? Because zinc, cadmium and mercury, these are having completely filled d orbital, means whenever you begin to write the electronic configuration of zinc, cadmium and mercury, you are going to get the D10 configuration. So D10 means electrons are completely filled. For that reason, these are, even though these are the elements of D block element, but these are not considered as a transition element. So here in the science, we are going to arise a question in such a way that which is the exceptional case. All the elements of D block are called as a transition element. Exactly right. But except the elements cadmium, mercury, zinc, cadmium and mercury. Especially they are going to ask such exceptional case only. So for that reason, here the D block element cadmium, zinc and mercury are not considered as transition element. Give reason. They will ask you. So be ready to give the answer for such kind of questions. Are you getting? So according to me, this is very much important for your examination point of view. Are you getting? Next one. So as the D block element are called as transition elements and F block are called as inner transition element. F block elements are called as inner transition element. So inner transition elements are nothing but here F block elements are called as inner transition element. So in the F block elements, lanthanide and actinides are there. So here almost all the actinide compound are radioactive element. You never get questions, but you should know this. Actinide, lanthanide we are representing the small Ln, and actinide we are representing as an AC. Ln means lanthanide, actinide. So all the actinides are radioactive compound. Radioactives are nothing but whenever we keep that elements in atmosphere, it is going to release some of the radiation. They are going to release the radiation. That compound is going to reduce regularly after one day, after 1 week, 1 month, or hundreds of years. So it means whenever we kept it in the atmosphere, it is going to radiate some amount of the energy or the rays. So such kind of elements are called as radioactive element. So the radioactive elements are actinide compounds. Actinide elements are called as radioactive elements. Are you getting this part? So this is about the overall SPDF blocks. So here one more some exceptionals are there. What are those means? Whenever you are going to write the electronic configuration of the element, based on that electronic configuration, you can able to say the position of the element. So already I have told you how to find out the position of the elements with the help of electronic configuration. Look here, whenever you write the element that is helium, it is having the atomic number 2. So elements atomic number 2 is having the electronic configuration 1s2. 1s2. So hydrogen is having atomic number 1 electron, that is 1s1, and helium is having the electronic configuration 1s2. Here can you see helium having the atomic number 2 and electronic configuration 1s2. So 1s2 means here outermost electron, that is having only one shell, that is s. If the outermost electrons are filled in s orbit, then to which belong, means to which block this helium should belongs? It should belongs to the s block only, because the outermost electrons is filled in s orbital. But we have kept the helium in the 18th group. Just look at the periodic table we are having. So the 18th group elements are called as noble gases. In P block it is coming. Actually I forget to say one more group is the P. So in the P block, the 16th group are called as chalcogen, and 17th group are called as halogen, and 18th group are called as, you are familiar from the 10th, it is called as noble gas. Noble gas, and it is called as inert gas, and it is also called as zero group element. Noble gas is nothing but they are rarely available in the earth. That's why it's called as noble gas. Inert gas are nothing but they are very stable in the overall periodic table. The most stable elements are nothing but 18th group element. That's why it's called as inert gas. Zero group elements are nothing but these elements are never going to lose the electrons nor going to receive the element. So metals are going to release the electron. For that reason, we are calling the metal carry positive charge, that is cation. Whereas anions are nothing but they are going to receive the electron. For that reason, we are calling that as a anions. So metals carry positive charge. For that reason, we are going to call that as a cations, and non-metals which are going to receive the electron. For that reason, we are going to call them as a anions. Keep in your mind. In the periodic table, actually the periodic table seems to like this. So this is S block element. So this is D block element, whereas this is the P block element, and below it is F block. So look here, in the P block, helium is kept in the P block, that is in the 18th group. 18th group elements are completely filled, means in the outermost shell, it is completely filled or fully filled electrons, or it is having exactly 8 electrons in the outermost shell. The elements which are completely filled electrons, in the outermost shell, or the electrons is having exactly 8 electrons at the outermost shell. And that condition, such kind of elements are stable. They are going to be form a inert position, means they are stable. They are not easily reacted with the other compound. Such kind of elements are called as noble gas, or those are nothing but the 18th group element. For that reason, the helium, even though it is according to the electronic configuration, we have to keep this in the S block, means second group. It should be placed, but we place it in the 18th group. Why? Because it is having completely filled electrons. Can you see here in the K shell, the number of subshell is only one, that is 1s. 1 means hydrogen, 1s2 means helium, means K shell is completely filled. So the helium being atomic number 2, it is having 2 electrons, and the first shell is completely filled. For that reason, helium is going to obey the noble gas property. For that reason, even though helium seems to be a second group element, it is placed in 18th group only because it is going to obey the properties of noble gas. It is going to obey the properties of inert gas. For that reason, 18th group element that is contained in the helium. Are you getting this point? So this is also the most important question for your examination point. Helium is placed in 18th group instead of second group. Give reason. Because helium is having the electronic configuration similar to the inert gas or noble gas, means the outermost shell is completely filled, which obeys the property of noble gas. Therefore, helium is placed in 18th group. Are you getting this? Is very simple question and most general answers it is. So, but you have to write it in a specific. Don't write generally. I hope you can able to understand this one. This is about the electronic configuration. So, and the next one is the properties of the elements. So, properties of the elements, these are most important. Let's begin that. So, before we move to the properties of the elements, so if I explain the properties of the element, means this chapter is going to finish. So, I need around 15 minutes to explain in detail. No doubt, whichever you have studied it in the SSLC, the same thing will be explained here, but still the portion is extended. That's all. Everything is same. So let's see some of the important terms here. So most of you already familiar about these concepts. So metal, non-metal, metalloids, and isoelectronic species. I think only the fourth one is new thing for you people, and remaining is very much easy. So metals are nothing but the elements which are going to lose the electrons. This is according to the chemistry I am speaking. So metals are nothing but they should lose the electrons, means they should carry the positive ions. How means? So where the metal you can observe in the periodic table. In the periodic table, you should remember, in the periodic table, the metallic character or metals are at the left side, and the greater metals are left side and at bottom. You should remember this one. for 1 marks you may get such questions. How means when I begins to explain the properties of them, properties of the elements, you are going to understand this is in detail. But you just remember, metals are nothing but all the non-metals are both are having the ions property. They should have the ionic. Ions are nothing but the element which loses the electron. Losing or gaining, they should carry some ions. If it lose means it will carry positive charge. If it receives means it's going to carry the negative charge. Look here, the metals are nothing but they should lose the electron, means it has to donate the electron. After donating electron, it's going to carry the positive ion. It's called as cation. Cations are nothing but positive charged ion. If it loses one electron, then it's called as plus 1. Lose 2 means plus 2. If it is lose 3 means plus 3. Similarly, those elements are in the periodic table. These are at the left side of the periodic table, and at the bottom the metals are greater. It means that at the left side in the periodic table in S block, at the bottom they are going to release the atoms. Means these atoms which are at the bottom of left side, they easily donates the electron. The element which easily donates the electron, those are having the greater metallic character. How on what basis we are telling, it will come to know in the next class. Okay, but you should know metals are nothing but they carry positive charge, and they are all the metals are at the left of the periodic table, and greater metallic character is at left and bottom, left of the bottom. Similarly, the non-metals are nothing but they are going to, according to the chemistry, they are going to receive the electron. According to the physics, we say that the metals are nothing but which carry the sonorous, having high melting point, lustrous, malleability, ductile. So these are all common things. But I am saying, according to the periodic table, how can we able to justify our ionic character or the charges? So based on that, I am telling you, you are not going to get such questions, but in your mind you should keep this. Whenever I use some terms, so you should be analyze that question or that formula based on these terms. So here non-metals are the they should receive the electron. It means when it receives the electron, they are going to form the negative ions. Negative ions means an ion, we are calling that as anion. If it receives 1 means minus 1 charge. If it receives 2 electron, then it's going to carry the minus 2 charge. So similarly, metallites. What are metallites? So here non-metals are at the right side, right of the periodic table, and at the right side, right of the bottom. So this is 18 group, except 18. You are not supposed to look at it. Except 18, that is up to 17. You can see. So here at the top, here the atomic size is very small. Here atomic size is very larger. So non-metals, they have a negative charge, anions. Non-metals are greater at the right side of the periodic table, and non-metallic character is very much greater. Greater non-metals are present at the right of the top. So at right of the top in the periodic table, the non-metals are having greater number. So what about non-metals? Metallites. So metallites are nothing but, can you see there is some zigzag movement in the periodic table. They are having. So here it is having one color, that is it may be a green. Here it may be a yellow or some color is there. So whereas here some portion zigzag movement, they have given some special color. So here it means that this is the border which is going to differs the metal and non-metal. So these are the elements which are going to exhibit the metal property. So these are the elements which are going to exhibit the non-metal property. But somehow these are zigzag elements which are present. These are called as the border which is going to differentiate the metal and non-metal. So here some of these elements are having the similar properties of metal and non-metal. For that reason, those are called as semi-metal. That semi-metal itself is called as metalloid. It is also called as semi-metal. What are semi-metal or what are metalloids? The elements which are having the both metallic and non-metallic character. That element is called as metalloids. For example, silicon, germanium, antimony. So these are the these are the elements of metallides. So still 2 or 3 examples are there. Commonly we are familiar with the silicon and germanium and timon. So these are the elements of metalloids. So coming to the last one, this is also simple. Isoelectronic species or isoelectronic atoms or isoelectronic elements. Can you see here iso means what? Same. Iso means same. The elements which are having the same electrons, the elements which are having the same number of electrons are called as isoelectronic species. For example, so for your kind information, if I say oxygen which is having the atomic number 8, atomic number is 8, it means that this atomic number Z is going to indicate the number of electrons. I hope you remember in the bridge course I explained you. Z is nothing but, and it is based on your high school also. So here Z is nothing but atomic number which is going to explains about the number of electrons. Here oxygen is having the atomic number 8, means it is having 8 electrons in the outer motion. So as it is having 8 electrons in the outer motion, oxygen is going to receive 2 electrons because it belongs in the chalcogen. 16 group elements are going to receive 2 electrons. Therefore, it is having the charge -2. Can you see here? Oxygen initially having 8 electrons. 8 electrons. When it carry the -2 charge, at that reason, initially 8 plus 2 electrons. Totally it is having 10 electrons. Isn't it? Is it clear? Initially it is having 8 electrons. 8 plus 2, it is having 10 electrons. So similarly, the 10th element, that is neon, which is belonging to the 18th group element. So neon, which is having the atomic number 10, it is having the atomic number 10, and it is having the 0 charge. Means it is having totally number of electrons is 10, but it is not losing the electrons nor receiving the electron. Therefore, the total number of electrons in the neon is 10, whereas fluorine, it is having the atomic number 9. Atomic number is 9, but fluorine carry the charge -1. It means that initially it is having 9 electrons, but it is going to receive 1 electron, -1. Therefore, total number of electrons is 10. Are you getting this one? Similarly, sodium. Sodium. What is the atomic number of sodium? Sodium atomic number is 11. So here sodium is belonging to the first group, that is alkali metal elements. It is going to donate 1 electron because the first group elements are going to lose 1 electron. Second group donates 2 electron. So sodium being the atomic number 11, it is going to donate 1 electron. Therefore, total number of electrons available is 10. Similarly, magnesium, it is having the atomic number 12, so it is going to lose 2 electrons. Therefore, 12 minus 2 is 10. Are you getting my point? So here, no doubt these are having the different number of electrons. Whenever they release the electrons, means whenever they lose the electron or whenever they receive the electron, they are going to occupy the same number of electrons. Same number of electrons. Therefore, this kind of the ions or this species are going to occupy the same number of total electrons. Such kind of species are called as isoelectronic species. For example, what is isoelectronic species? The elements of the species which are having the same number of electrons are called as isoelectronic species. For example, you can write oxygen. Don't write only oxygen. Oxygen, which is having the charge -2. Initially 8 plus 2 10. Fluorine having the atomic number 9. After receiving 1 electron, means F -1. This charge should have not -2, it should have F -1 only. And then sodium, when it loses 1 electron, plus 1 charge, and it is having 10 electrons. Similarly, magnesium, after losing 2 electrons, these elements are having the exactly the electron 10 in its electronic not configuration. In its group, it is having exactly 10 electrons. For that reason, this kind of species are called as isoelectronic species. Are you going to get? I hope you can able to understand this one. So in the next class, means it will be the last class of this periodic classification. So if you are having any doubts, feel free to ask, and before that last class I will tell you the some important definitions with notes I will send you, and remaining you have to practice that one. Try to analyze the question and answer, and if you didn't understand any concepts, try to understand. If not, means I'm there to clear your doubts. Okay, we will meet in the next class. Have a nice day. Bye.